Okay, everybody's comfortable, had a nice lunch, feeling a bit sleepy. Yes, the day's not ended yet, and hopefully I can actually scare you guys a little bit. This is a topic that scares me quite a bit, and that's security in applications. And I'm going to show you how to secure your public-facing applications, especially if they're Java. I am a member of an organization called OWASP, which is the Open Web Application Security Project. They do great things in the community. They have a strict code of ethics, and I abide by those ethics. I don't hack. I don't try to break into other people's systems. I think that's very bad. Yeah, very, very bad stuff. So I'm a white hat, as they call it, not a gray hat or a black hat. And yes, hopefully I can show you some scary things. So who here has hacked before? I'm not talking about breaking into something and stealing some money, but who here has hacked? And most people have. You can't admit it, but who's that guy that leaves his computer unlocked at work? Yeah. And yeah. Have you fiddled with somebody's PC before? Good. It's actually a very good thing.
Send bad emails from them.
Yes, send bad emails. Send like forged emails or something from the guy's computer. And it's actually a very good thing because it teaches you to be more security conscious. And one of the things that somebody at our company does is set the homepage to mantis.net, which is actually some very frilly mantis. Yes, they're actually live. You can go buy stuff from there. Yes. So, have you ever guessed somebody's password? It's the name of their dog. Yes, or password or something really stupid. Have you had your password guessed that you know of? My daughter, she's like 6 years old. She sees me type on my phone, and she quickly remembers the sequence of numbers. And while I'm not there, she types it again. And it's very easy to break in. And have you ever reused a password and had that used against you? Okay. I'm not a young guy, I suppose. In my early teens, I had a BBS. Who remembers BBSs? Bulletin boards? The days before the internet. I had a BBS on my computer, and my friend had a BBS on his computer. He logged into my system and created a user. And he stored his password there, and back in the day it was stored in plain text. And I logged into his system, and I could switch from my user to his user because the password was exactly the same. And I actually went in and I deleted files. Okay, I was 12 years old, we were very naive, but to this day, hackers use that approach. If you reuse your internet banking password on another computer or another site, or somebody can somehow get hold of that password, yeah, don't share your internet banking passwords. Anyway, yeah, anyway. So, has your company been hacked that you know of? And was it a piece of code that you worked on? Yeah. Okay. This is a very important question. Has your company been hacked and you don't know about it? Exactly, it's a scary, scary question. I mean, when Heartbleed just came around and people kind of noticed or were told, oh, but your private key may have been exposed for a couple of months. And if you're securing billions of rands or dollars of transactions, that's a very scary thing. Hackers usually use the easiest way of getting into your system. Okay, like a shared password. Some sysadmin would reuse a password and they would log into your system and reuse it or gain access and do some nasty stuff. But sometimes they actually use very sophisticated mathematical stuff. And that is also a very scary thing I'll talk about. So software engineering is not equal to classical engineering, especially if it's exposed on the internet. So your software that you develop, if you expose on the internet, who exposes their software on the internet? And behind there is a whole bag of coins, right? Now, people can actually devise new ways of breaking into your safe every day. And you'll never actually meet these people. They could be in China, they could be in the US, they could be 12-year-old little boys down the road. They could be breaking into your system just because they're a bit bored. And, okay. The next point of the conversation, who knows what a hash is? Well, it's right over there, right? So what a hash is it takes a bit of input and it gives you a hexadecimal output. And that is kind of the fingerprint of the system. Very, very easy. So here's a secret being hashed. Secret with a capital S, it's completely different, and here's an image being hashed. So that's fairly simple, right? So hashes are the cornerstone of securing data on our internet. What digital signatures use hashes underneath. So that certificate from VeriSign or whichever CA that you got your certificate from, that has a hash on. So can somebody explain to me, please, why these two images over here have the same hash? Hash collision. Very simple. And my wife says that Amazon is a terrible thing. It's very terrible. She keeps on asking me, why am I behind my computer again? And I tell her, well, I can't buy this car, I can't buy this computer, so I have to rent it. And generating that collision cost me $1.68 on EC2. It's got GPUs. Now, hackers have all of this hardware at their fingertips to break into your zip, your encrypted zips, to break collisions between hashes. And MD5 is, for about 10 years, it's been considered insecure. Now SHA-1, SHA-1, is now broken as well. I think it was November last year, Chrome started displaying that SHA-1 was not really trusted anymore. Soon, even Internet Explorer is going to have a warning against this. Believe it or not. They're a bit slow on the uptake. Yes, so SHA-1 is estimated it costs $2,000 US to crack that. And that's quite scary. I mean, if your company is a bank and you have millions of dollars of coins in the back there, $2,000 is not much. I didn't have $2,000 to prove a point, but it's quite easy in theory. So in the Java world, you'll still find SHA-1 quite a bit in Maven Central. So all the hashes in Maven Central are MD5s and SHA-1s. In digitally signed code, they are signed with SHA-1 still. And in the Spring Maven repo, the certificate is signed by using SHA-1, and that's hopefully that will change very, very soon. Incidentally, back when MD5 was broken, 2008, I think, somebody published a paper about rogue certificate authorities, where they actually said we can create a certificate authority that looks like GoDaddy's certificate authority, and then sign another certificate for your favorite bank. Where do you bank? Yes. Oh. Well, sign it against that. And you would log in, give your password, and they would steal all your money. Very, very scary stuff. It's not as easy as breaking a hash. Yeah. So Chrome, Firefox, and even IE is phasing out SHA-1. There's a project called HashClash. And underneath there's a rogue CA, if you can have a look at that link. So now we have a sample application. It's kind of new, not really. It's Java 7. It's the last public update. Who uses Java 7 in production? Exposed publicly on the internet? Okay, we'll see. Okay. Apache Tomcat 8.0.28, latest release. We've got Spring Boot 1.1.10. We've got Apache Poi. We've got jQuery and a few other things. We've got Bootstrap. So that is the attack surface of my application. Okay, it's not my operating system. It's not the firewall. It's my actual application. So this is what my project actually looks like in all its dependencies. And this is checked out from Spring's repository. It's one of their demos. So now my attack surface gets kind of hairy when it comes to this point. I mean, that's a lot of dependencies. So Java 7 Update 80, the last public release. Non-public releases have 45 security fixes on it. So if you go pay Oracle for having custom versions of Java 7, you would have received 45 fixes. That includes fixes to SSL and TLS. So yeah, that's a bit scary. Java 7 only supports TLS 1.0, which is very, very, very old. There's a couple of attacks just on that. The max def-Hellman key size is 768-bit. Okay, if you use the ICT version of Java, you can actually get 496 on Java 7. So if you apt-get install OpenJDK 7, you'll actually get a better version than Oracle provides. And it's actually, you can play logjam against it. The def-Hellman key is hard-coded into the JDK. Okay, that means that millions of people out there are using the same key. So people can devise an attack that attacks Java and Java 7. And that's very bad. There's a website called weakdh.org, and you can check if your website is vulnerable to that. It doesn't support GCM, which is a replacement for CVC encryption, or cipher feedback. Okay, so Apache Tomcat 8.0.28, which is the latest version of Tomcat, it's got 3 vulnerabilities. You can see CVE means it's common vulnerability, and this is a year, and these are the numbers, which are never a sequence apparently. On purpose, they don't want to say when a bug was actually realized, so people can figure it out. Okay, now Apache Poi, which was in our attack surface as well, it's got a couple of other little vulnerabilities here. You probably can't see this, but this version of Apache Poi 3.8 allows remote attackers to have a denial service, infinite loop, and deadlock with a PowerPoint file. I mean, yeah. So this can go and lock up your thread, and if there's only 30 threads in the pool, it can lock up all the threads. Denial of service. Yeah, that's quite a bad one. Then there's another denial of service with another file format. It's the OpenOffice XML file. Here's another one for Apache Poi. Allows remote attackers to read arbitrary files. That's very bad. Okay, so I can potentially go and upload an Excel document or some other document and get hold of your private key, get your private key passphrase, maybe download the thing. This is very, very bad. And another one, this gives you an out-of-memory error, crashes your JVM, denial of service. It's quite nasty. And how do attackers go and exploit these things in open source software? So the first thing I would do if I was a bad guy is I would go and browse the bug database. So if somebody goes and logs a bug and says, if I submit this certain file, it crashes my JVM. And then I think, oh, this bank over here or this guy allows us to upload Excel files. Okay, let's try it and see what happens. I can be 12 years old. I can be a little kid, and I can bring down a major organization. I can compare the changes in the source code. So if people try to hide that there is a bug or a fix, a security fix, I can actually compare version 1 and version 2 and figure out, ooh, let's go and exploit that issue. I mean, people have a lot of time on their hands and there's lots of money to be made. So I don't know if anybody can see this, but spot this piece of, or spot the bug in this piece of code, or the bugs, plural. Can you guys see this?
Potential will overwrite the byte array.
Sorry?
There's a big potential that whoever does the work will overwrite the byte array, because there is no definition of how large the byte array is when you do the work.
Yeah, very true. It's true.
Possibly cross-site vulnerability, return back the name to the tribe, unencoded.
Ah, okay, very cool.
Connection leak.
Connection leak. I would see that. You open up a connection here and you close it over there. I don't know why developers don't. Yeah. Try with resources, people. How about
Raw reading,
yeah?
reading the entire byte stream into memory.
Yeah.
You have no idea what it's in it, and you have no idea how big it is.
It's like a petabyte. It's like
Just feed like over
yeah.
and over and over.
Just crash the JVM. It's just like scary stuff. And people on the internet can actually just browse your code, open source software. Okay. So open source is like very insecure, right? Because it exposes the guts underneath. But actually no, because people are viewing that code and they're trying to figure out what's wrong here, they can quickly go and fix this issue. I mean, somebody will put in a pull request to actually go and close that connection over there and remove that get bytes, which is quite cool. Now, OWASP has a plugin which costs a whole of nothing. that actually you can just add to your Maven or your Gradle plugin, or it will tell you all the dependencies. You can tell it to break, and it tells me that POI 3.8 has got this certain vulnerability. Very easy. It tells me that my embedded Tomcat, a part of Spring Boot, actually has a vulnerability as well. Okay, that's quite easy. So there's an easy way of preventing these kind of things and breaking a build. Which brings us to another question. Okay, I download my Maven dependencies. I'm using Gradle or whatever build tool. I'm downloading it from the internet, right? What's the problem with this? Exactly. So where did I get this piece of software? I don't know. Yeah, exactly. And anybody that runs the Microsoft operating system, I don't. You download something to print to a PDF, and it comes with a whole bunch of spyware. Maybe it comes with a couple of viruses. It's just standard practice. Don't trust what actually is out there on the internet. Don't trust HTTP. There could be a man-in-the-middle attack, and I'll get to that right now. There is a man called Max, I can't say his last name, and he devised this little trick where he did a simple Joda time application, and then he deleted that Joda time application from his Maven repo, and he downloaded Joda time via a proxy, obviously a poison proxy, and when he displayed the time, he could actually show this little picture of swing of a black cat. Hackers won't put a black cat on your screen. What they can do is create a backdoor into your DMZ. They can go and mine data. They can go steal passwords. They can email stuff. They can do some very, very nasty stuff. So you may think that your network is completely secured, but meanwhile, that piece of software that you downloaded is not, well, what you think it is. It's a black cat. So upgrade your Maven, please, people. Or your Gradle, I'm sure Gradle will. Gradle 332, I think, uses HTTPS by default because of this man's blog, which is awesome. Okay. So my sample applications, what happens if I upload a huge file, like we discussed previously, it may actually crash the JVM. But in this case, it's giving me a couple of other things here. It's telling me HTTP 500, internal service error. It's telling me org Spring framework. Oh gee, thanks. Thanks for telling me you use Spring. I'm going to go browse the Spring bug database and try to figure out if there's a bug with Spring security. And believe it or not, there are a couple that you can actually override that. It's telling me that the configured maximum is this amount. So, gee, thanks. Let me launch a denial of service with like 60 threads with that exact amount and see what happens. Yes, so we've exposed some internal stuff to our end user that we should not have. jQuery and the JavaScript world is also very scary. And if you're using an outdated version of even AngularJS or jQuery or anything, it could actually be vulnerable to a whole bunch of things. So here's my little Spring demo to upload some data. And I've installed a special little plugin into my Chromium. And it actually shows me exactly which vulnerabilities it's vulnerable to. So when I browse to a web page, I can see that Stack Overflow is vulnerable to this XSS implementation. And actually, it happens. I mean, it doesn't mean that people are going to break into your website because there's a vulnerability. It just means probably it's a good idea to upload it. Retire.js also has a Maven repo, a Maven plugin, where you can just add it to your Maven build, and it will tell you that it's vulnerable to these certain vulnerabilities. So the main theme here is upgrade your libraries and your tools. You need to actually deploy more often. An application that is a year old and its dependencies haven't been upgraded, that's a very bad thing. If your closed source application server relies on underlying open source libraries, there's actually a OWASP tool that you can actually go and fingerprint these things underneath. Even though WebLogic doesn't want to tell you what's underneath there or which versions, you can actually figure out from that. So there's another tool, Firesheep. Very, very scary tool. There's a Wi-Fi here, right? Right?
Yeah.
Yes. Okay. Now somebody, being not me, can actually listen on the Wi-Fi network, and they can listen for sessions, and they can try steal your sessions, because this is not really a trusted network. All of you guys are trusted, right? But in a coffee shop, somebody can actually go and steal your session to certain things and try pretend to be you. Java has a session ID that it stores in a cookie, or sometimes it puts it on the URL, very bad. Even a proxy can intercept that. Firesheep can help you steal those things. Yes, okay. Now, Maven repo. How's its SSL? Well, I went to SSL Labs and did a quick scan, and actually it has a lot, yeah, it's very good. I mean, I struggled to get an A using Java 8. So it's quite good. Repo.spring.io, very bad. It uses weak Def-Hellman keys. So that means that it's shared among many, many, many people. It doesn't use a certificate that uses SHA-2. It uses RC4, which is very, very old. It also is susceptible to denial of service attacks. Somebody devised a little technique where they could ask the SSL provider to renegotiate the connection, and it takes the server a lot longer to renegotiate than the client. So the client can launch multiple attacks across one TCP stream to actually crash that server, or at least bring it down to a very, very slow halt. Since it's a Maven repo, this is probably not the end of the world. But if your bank has got a rating of B, which one of the banks in South Africa does, yeah, just be aware. Yeah, I won't say. You can go check. So how secure is your Wi-Fi password? Okay, don't share your passwords, definitely not. How long is your Wi-Fi password at home? How many letters? 12. 63. Well done. Does your password at home end with numbers?
Yes.
Yeah, quite often it does. And hackers kind of know this. So on EC2, you can actually go and use a GPU instance with 32 processors and build up a way of actually guessing somebody's Wi-Fi password. I don't know how this actually works, but I mean, the router should actually break it, but there's a something on Google Code that allows you to do this. Yes, numbers at the end of the password are not good enough. Lead passwords, I mean, that's like whole 2001 kind of passwords. That is not secure. Don't use that. Put an @ somewhere else. Not where a. Sorry? Oh, didn't get that. Okay. Use, I think, 12 characters instead of 10. using one more character, especially if it's not a number, makes your Wi-Fi password a lot more secure. There was a joke where somebody had their Wi-Fi SSID or whatever set to crack this or break this, and the next day the person came back and it was changed to challenge accepted. Yes. I like passwords like this. So something I remember that I don't write down. There's something called S-key that will actually generate some sort of random long generation. So that's my personal preference. And I hope that freaks you out a bit. I mean, I thought Java security was make sure that you do prepared statements and then you don't concatenate your strings with your SQL. Yeah, that's pretty much it. If you weren't using browser-based Java stuff, so, yeah, my stuff is secure, right? Turns out it's not as secure as you thought. So upgrade your libraries and tools, please, people. And don't bury your head in the sand. And any questions?
Do you think using service like LastPass is a good idea?
Sorry, what is LastPass?
LastPass, it's an online repository for all my other passwords. Use browser plugins to log into my service. So it's basically one password, one master password, and all other passwords are generated at random and stored on their service, which is the one vulnerability that algorithm can
Yeah.
serve.
Yeah, probably a bad idea. I mean, just think how you would break into that system. Just have a think. I mean, how would I break into the system if I was a bad guy? I don't know, you tell me.
So you talked about updating your libraries, but isn't there a possibility that this new library might have more security flaws? So how can we actually check for that?
Well, this plugin is very good, the OWASP plugin. Don't blindly go and update your libraries. But this plugin over here, it's quite well maintained. Yes, and it links to the bug database, the common vulnerability database. There's a Jenkins plugin for it. You can break your builds on it. Probably a good idea, especially if it's public facing. Yeah, that's it.
May I please add that when you do upgrade your Maven to use HTTPS, please don't ignore the serve errors, because that's the first thing that happens.
Yeah. And who works for a large corporate around here? Quite a few. So you know that a lot of the big corporates like to do a man-in-the-middle attack. So yeah, SSL inspection. I mean, they want to know exactly what is going on. So they have a fake SSL WebSense CA, I think that's the main one that they use, that they have on their proxy, and they manually go and install that certificate authority onto your machine. And when you Control-Delete and you in Windows, and you see that little message that says blah 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 blah, this is our stuff, we're actually inspecting what you're doing. Yes, they actually are, because that is not secure. When you log into a banking website, then they allow it to be the real certificate. But if you log into Gmail or Google or something else, that certificate is essentially forged each time. And people just turn off CA validation on the Java side. And yeah, They expect it's going to be a good thing.
So what do you think are the top actions that teams, organizations should take to protect themselves biologically? You freaked us out. Do you have some concrete recommendations? Obviously, you integrate this stuff into your
Yes.
CIs. Is there anything else?
Yes, it's a very good question. OWASP itself has a huge resource of documentation. They have their OWASP top 10, where top number 9 is actually using outdated or using dependencies with known vulnerabilities. Number 1, I think, is SQL injection. Another one is giving your attacker some knowledge of the underlying system, like that exception. So we know that it runs Spring and maybe Spring Boot. There's a whole bunch of other ones. But OWASP is definitely a good resource, 100% free. They have another thing called OWASP Zap that actually analyzes websites. It's not recommended that you go and browse your corporate website with this thing because it could actually do something bad. You can actually, there's an attack button where it actually tries to do exploits onto that system. But on your local QA, maybe you can try run that. You can build in the vulnerability check on your JavaScript stuff as well. 100% free, doesn't cost you anything. Session hijacking, also it helps you prevent that stuff. Session hijacking is very, very scary for me. If somebody can get my session and then pretend to be me on another location and log into my internet banking or whatever, it's a very bad thing.
I just want to also mention that OWASP people, they do have a Java library that helps you, it actually helps you code in a way to prevent all these security vulnerabilities. So they actually provide a bunch of default implementations that intrusion detectors, access controllers, different HTTP utilities. They have a lot of stuff, so they provide default implementations via factories and interpreters, but you can obviously override it to fit within your organization. I've been using it for the past 4 or 5 years now, and they are actually actively maintaining it. I think they've just stopped on version 2. They're now deprecating it, and they're now starting on a new branch on GitHub
nice.
also. And yeah, it would actually be cool, or you can start contributing to that on GitHub. Actually, it's a very interesting project.
Oh, very cool. Open source. Thanks. And free software.
Just to point out that security is really, really hard. People, the recent project experience was like just kind of half-assed. They read a little bit of the doc, do some string auth stuff, and whatever. It's gonna be fine. It's gonna be fine. That's not gonna cut it. Like it is a tough thing, and if security matters to you, it is worth spending the time or also the money on potentially getting outside help to do that. And then there is no real security, so it's also worth thinking about whether you really want that to store that particular information, or be kind of cautious and want it to actually have that could be potentially interesting.
Yeah, for sure.
What's your advice in terms of, for like general people, internet and post-Snowden revelations about obviously NSA vacuuming up all the data and having these supercomputers to pretty much crack anything that's out there? I mean, are we actually safe? All this encryption and thing, are we just deluding ourselves? what's your opinion on that?
Some people try to prove that RSA has already been cracked by the NSA for a very long time. But most people have actually rubbished that. RSA is very old, and I don't think anybody really has attacked it. There's no proof against it. There's people that are trying to break this stuff 24/7, and the guys that broke MD5 initially, it's actually from China. They released these papers. They quickly released that, and they didn't release how they broke it, but they at least pushed it along to the right people. Yes, if the American government is spying on me, I don't really care. If somebody's going to try to steal my money or try to break something or do something bad, I'm more worried about that. Yeah, Big Brother's always there, and they always have bigger computers than EC2 with bigger GPUs. GPUs are scary. I mean, you can actually break AES-256 encryption on a zip file in a couple of minutes on using GPUs. I mean, if your password is short enough, it's going to happen very, very quickly. That's it.
Thank you very much, Richard.
Good.